Hi everyone. Today we're going to go over section 4.2. This is the second to last section in our unit 4 before our test. Alright, last class we talked about solving systems by graphing, and I'm going to use the phrase, when in doubt, graph it out. If we are ever stuck on our final or your test coming up here in a couple weeks, if you're ever stuck, you can always revert back to graphing. That is the one thing we want to know how to do as we go into semester 2, is how to graph. All right. If you remember at the beginning of the semester, I talked about the multiple ways in which we can get our answers, especially in math. We can get the same answer, but in a different way of approaching that. Okay. That is going to come into play today as well. So we learned how to graph last class. We're solving systems by graphing. So we're seeing where those two lines are going to cross each other by graphing. And today, we're going to use another method, but either way, it's still the same procedure. We're seeing where those two lines are going to cross each other, intersect each other, and be the solution. So last class was graphing. Today's class will be substitution. Now, if you like graphing and you are solid on graphing, by all means, stick to graphing. All right. Again, that's the one thing we want you guys to know how to do. Substitution is just going to be, for lack of a better word, it's a shortcut. It's another method you can use depending on the types of questions that you're given. And I'll kind of touch on that as we go through our notes today. All right. So to get started, why would we choose the substitution method? Why would we not want to use graphing? Again, we can use graphing if we want to, but there is a reason, the shortcut reason why we would want to use substitution in certain scenarios. All right. And those are the first 4 bullet points listed on your paper. So if we want to do the substitution method, the first thing is a variable, typically y, is going to already be solved for. It's going to be by itself in one of your equations. We'll talk about that in example 1. Another option, or another reason why you might choose the substitution method, is that since that variable y is going to be solved for, it's going to be all by itself, you can then use the substitution method to plug it in and solve for x. So think substitution, think just like a normal game of basketball, for example. If I were to substitute in a player for another player, you're replacing the one on the court for the one that just came off of the bench. All right? You're not going to leave the person that was on the court and add the person from the bench. You are swapping them out. You are substituting them out. This is the same situation. And once you solve for x, you can plug in the new value and solve for y. And then you can always, always, always check your solution. All right, so we're going to try this procedure together. And we got 5 examples to work on. And again, this is just another method. When you guys take your test here in a couple weeks, you will be allowed to choose whichever method you prefer. If you like graphing, use graphing. If you like substitution, use substitution. All right, same thing goes for your final. They're not going to be evaluating a specific way of solving, so you guys are good to solve the way you know how. So we will get started on example 1. And the question asks, what is the solution of the system of equations? Keyword, solution. Just like when you guys saw this in the last set of notes, last class, we asked what the solution to the system of equations were, but we couldn't figure out that solution unless we went to graph. Well, today we're not going to graph, we're going to use substitution. And in fact, I tell you which method to use so we can get that practice in. And if you look back here at our very first reason why we would choose the substitution method, is it says that a variable, typically y, is already solved for. So if we take a look at our 2 functions in example 1, we have y equals negative 9x plus 6, and then 2x plus 3y equals negative 7. And when you look at that first function, yes, it's in slope-intercept form. That's good that we can recognize that. But it's also with y all by itself. And so the reason why we would use substitution this time and not so much graphing is because this isn't in y-intercept form. That second function is in what we call standard form, all right? I can most certainly put it into slope-intercept form, just like we did last class. That is not a problem whatsoever. But it's much easier in some scenarios to take everything your y value equals in the first function and swap that y out in the other function. That's what the substitution method is telling you to do. So let's go back one more time. I know that the first function tells me, hey, y is going to equal all of this. It's going to equal negative 9x plus 6. That's your first function. I can take that exact function and substitute that in for y. And the reason I can do that is because y is already identified in the other equation. It's already by itself. So when I do that, I am going to perform a full substitution. Think about your basketball, okay? If I'm substituting out a player, then this y in my second function is getting completely swapped out for this whole function here. And I'll show you how that works. You're still going to have the 2x, nothing changes there. You're still going to have a 3, but now when I see that y, I'm going to replace it with that exact function that I know y has to be. And of course, whenever you swap things out, always remember to use parentheses. And then if you look here, everything is now in terms of x. You no longer see any y's. So now it becomes, okay, well, let's solve for x, much like we did in Unit 1 and Unit 2. So I can continue by distributing this 3 first. Remember your order of operations. You're going to get negative 27x plus 18. And it is still equal to negative 7. All you did right there was distribute that positive 3. And it's a solving game. Notice how all of your x's are on the same side, so that's good. We can combine these because they are like terms. 2x minus 27x is going to combine to give me negative 25x plus 18 equals negative 7. Again, we're solving for the variable. In this case, my variable is just x, so I want to get x all by itself. So I need to subtract an 18 to both sides, work down. Negative 25x is now going to equal negative 25. That's nice for us. And last but not least, to get x all by itself, I'm going to divide both sides by negative 25. And I'm going to get that x equals 1. Okay, now you got your x value. Think about what that means. When these two functions are graphed, if I were to use the graphing method, I know that they are going to intersect at the exact same x value, and that x value will be 1. But remember, there's one extra piece that we're forgetting. We have our x coordinate, but we always also need our y coordinate, just like when we solved by graphing last class. So now that I know what x is, I can look back at this original function, either one, honestly, either one, but this one already has y by itself, so I'm going to go back to that function with y already all by itself because that's the variable I'm missing. And if I just plug in and resubstitute my x, much like you guys did with your h charts, I can figure out what my y value is going to be. And when I do that, I get y equals negative 9. I'm plugging in a 1 for x and adding 6. Again, you can use the calculators when you get to this part. You have your parentheses. Make sure you're using the correct minus button or negative button. And this should come out to give you negative 3. Now I have my x, I have my y, so together I know my answer is going to be at 1, negative 3. Again, if you like graphing, there is nothing wrong with graphing, but we do want to touch on all methods of solving. So there's graphing and there is substitution. This is the substitution method. You see a variable is already all by itself, so we're going to substitute the entire function in for that variable, and we revert back to solving. Solving is key here. So our answer to question 1 is 1, -3. Let's try question 2. Moving to the right here. I have two functions again, and it's asking me for the solution of the system. So the same thing, where are these two lines going to cross each other? And I have to use the substitution method. So I take a look at my two functions. This function has y all by itself, and I say it's equal to x minus 6. All right, the second function, yes, it does have y by itself, but it still has that negative out front. So technically, y isn't completely solved for right at that moment, but that's okay. And it's still equal to x minus 10. All right, well, let's go back to the first function one more time. My y is all by itself. It's ready to go. So I'm going to take this entire function that y is telling me it equals, and I'm going to use substitution and plug it in for the y in the other equation. Now remember, the second equation still has that negative out front. So when you substitute, that negative has to stay. And you're plugging in an x minus 6 now from your previous equation. And it still equals x minus 10. You're using substitution. You just swapped out your y for that function. And now we revert back to our order of operations, our PEMDAS. Well, remember, we have to distribute. This is technically a -1, so we have to distribute a -1 to both values inside those parentheses. So that gives me -x, or -1x, plus 6, and it still equals x minus 10. This time, I have x values on both sides, but I'm not allowed to have them on both sides. I want them on just one side. So I'm going to move the x, and I like to move the one that's on the right. Well, currently it's a positive x, so I want to subtract an x. And whatever I do to one side, I have to do to the other. Make sure if you're subtracting on one side, you're still subtracting on the other. Don't lose track of your symbols. Now let's work down. -x minus x is going to give me -2x. Bring down your plus 6. X minus x is going to cancel, which is nice for us. And it now equals -10. We continue to solve. I want x by itself, so I'm going to subtract a 6 to both sides to move that positive 6 over to the other side. That's going to give me -2x equals -16. And last but not least, dividing both sides by -2, and that will tell me that my x value has to equal +8. Again, that's just your x, but we need both our x and our y. So we're going to make sure that we take this x value, go back to the original question, the original function, and I'm going to swap out x with the number 8. So that's going to be over here on the right here. Y equals my new x value of 8 minus 6. Simplify. Y equals 2. And now I have my x value and I have my y value, so I can make the coordinate 8, 2. And you have now officially solved by substitution. All right, make sure you include both coordinates. If you can solve for x, then you can plug in that x one more time and solve for y. And again, take a look at the functions that you're given. All right, one is already in slope-intercept form, the other one is not. So yes, we can use graphing. However, if we were to graph that second function, we would have to manipulate the function a little bit and get it into slope-intercept form, and then we'd be able to graph. All right, it's really just a matter of choosing which one you prefer. If you like graphing, you can stick with graphing. But if you notice that one is in slope-intercept form and the other one is not, you can use substitution. It's an easy method to just plug it in work it out, and solve. All right? That is the reason why we might choose substitution over graphing at the end of the day. So let's do question 3. Same thing. Solve the system of equations using the substitution method. So we're going to go in. We see that we have y already by itself, and it's telling me that y equals all of this, 2x minus 1. I'm going to take all of that, and I'm going to substitute that in for the y in the second equation. Now remember, just like in basketball, if we're going to swap it out, we are only swapping out one thing, okay? If I had a substitution happen in basketball and I sent a player off the bench into the game, is the player who's currently in the game going to grab another player and walk off too? Okay, no, they're not, because they're only 1 for 1. You're swapping out one y for the other y. So if there's anything extra, like this 3, for example, that has to stay. You are only swapping out y's for y's. Nothing more, nothing less. All right? So when I swap that out, when I use substitution, I still have 2x plus 3, but when I approach that y, I'm going to swap it out with 2x minus 1. Again, make sure you're using parentheses when you substitute things in and out so that you can remind yourself what's truly happening. And it still equals negative 7. I took the exact same function, but the only thing that got swapped out was my y. And now we can continue by solving. Distribute that 3. Remember your order of operations. I still have a 2x out front, and it's still equal to negative 7. Then we have 2x plus 6x minus 3 equals negative 7. Take a look. You have both x terms on the same side, so we can combine them as is because they are indeed on the same exact side. So 2x plus 6x is going to give me 8x minus 3 equals negative 7. Continue solving for x. We're going to add 3 to both sides. Remember, if you're adding 3 on one side, you're going to tell yourself to continue adding 3 on the other. And we are left with 8x equals negative 4. Again, use that calculator if you need to. You're allowed it on the final. You're allowed to have it on the test. And last but not least, in order to get rid of that 8 on your x, we must divide. And at the same time, let's reduce that fraction. Negative 4 over 8 is indeed going to give me a negative 1 over 2. So yes, our x value will be a fraction. That is okay. We can survive. Now I have my x value. I have the x coordinate, but I need to know my y coordinate. So we're going to go back to the original where y is still by itself because it will make things a lot easier to solve for. And now this time, wherever I see x, I'm going to plug in negative 1 over 2. And again, fractions are nice. You'll notice that when I distribute 2 times negative 1 over 2, that will reduce that fraction, or that will cancel it out to give me a nice negative 1. And negative 1 minus 1 more will give me negative 2. I have my x, I have my y, so my final answer will be negative 1 over 2, comma, negative 2. X first, y second. Practice that substitution, all right? Even if we like graphing more, tonight's homework will just be substitution method. But by the time you get to your final and your test, you can choose whichever method you prefer. Going into example 4, same thing. Try this one on your own. You can pause the video if you'd like. Give it a shot. You will see something interesting happen. We will need to remember some background information. So same thing, the first function, y is already by itself. So I'm going to plug all of that function, negative 2x plus 5, in to our y on the second function. Now, before I do that, notice that your coefficient, that number in front of your y, is a 1. We're still going to have to distribute like we normally do. So we have 2x plus 1, parentheses, negative 2x plus 5. I want us to remember our steps to distribute and to use PEMDAS and what have you. That's why I want to include that 1 as my coefficient. So now I'm going to practice distributing. That gives me negative 2x plus 5, and bring everything else down that I haven't touched. I see my x terms are on the same side, so I can combine those. 2x minus 2x is going to give me a 0x, so those are going to go away. And I'm left with 5 equals 5. So the fact that those variables just went away, your x variable just became 0, we are now stuck with either no solution or infinitely many solutions. And the same rules apply as we talked about before in Unit 2 and Unit 3. If we have a true statement, we will have infinitely many solutions. It's always going to work out. Any values that you plug in for x or that you plug in for y are always going to work out for both equations. If it comes out false, though, you will have no solution, meaning that no values for x and no values for y are going to be the same for either function. So looking at our final work here, we have 5 equals 5. Ask yourself, well, is that a true statement? Yes, it is. And since that is true, we can stop our work and say we have infinitely many solutions. So many, in fact, that we cannot count them ourselves. If we were to graph these two functions, remember what a graph of infinitely many solutions would look like. You would have your first line, and then when you graphed your second line, you would notice that it would be the exact same thing. Test it out. If you want to try graphing this one, you most certainly can, but you will end up with the same exact function. Hence why we have infinitely many solutions. And last but not least, let's try example 5. Same steps. I want us to practice using the substitution method. This one is a little bit different though. Take a look at both functions. Both functions are set up in slope-intercept form. So instead of substituting, if I wanted to on my test, could I use the graphing method? Yes, I most certainly can, because they're both in slope-intercept form. It's ready, easy to go, and we can continue on. All right, but because of this question asking for the substitution method, that's the one I'm going to show, but it's the same procedures. Your y value is equal to negative x minus 4. Take a look at the second function, and you're going to swap out that y for negative x minus 4. It just so happens that y is already by itself on the left-hand side, but we're going to continue the same process. So we're going to get negative x minus 4 equals negative x plus 5. Our y's have disappeared because, again, we substituted. We replaced them. And now we solve for x. Well, I have an x on both sides of the equal sign. That is not allowed. So I'm going to add the x that's on the right side over to the x that's on the left side. And now I can work down. Well, negative 1x plus 1x is going to give me 0x. Those are going to cancel. And the only thing I'm left with on the left-hand side is a negative 4. We'll do the same thing to the right-hand side. Negative 1x plus 1x, again, cancels out, and I'm left with just 5. Well, all my variables are gone, so I have no sort of solution to figure out. I have to now look at what's left. I got negative 4 equals 5. Is this a true statement, or is this a false statement? And you will notice that it is in fact a false statement. Therefore, this will never occur. They will never touch one another. So we have no solution. Again, if I wanted to graph these, take a look at both of their slopes and the original functions. Y equals negative x minus 4, y equals negative x plus 5. They're both in mx plus b form, so if I wanted to graph them, I most certainly could have. And my slope would be the same in both scenarios. Well, if our slope is the same in both, we know that we're going to have parallel lines, so it doesn't matter how it's going to look, but when I do go to graph these, what do you notice about parallel lines? They are never going to intersect, therefore there is no solution. All right? This section of notes is all just a matter of preference. We're showing you both graphing and the substitution method so that you can get your practice on which one you prefer. Again, on your test, you will get to choose which one you like the most. If you want to bounce back and forth between graphing and substitution, you most certainly can. Your test will give you both graphs and plenty of room. So if you want to choose graphing, you can graph. If you want to choose substitution, you can use substitution. Or maybe you want to do both so you can check your answers. That's most certainly probably the best idea, actually, so that you can verify your answer is correct before you turn in your test. All right. Your homework tonight is going to be on the substitution method, so I do want you to practice the substitution method so you can get that in and practice it. But at the end of the day, you can always choose which method you prefer. All right. If you have any questions, please let me know. You will also have a quiz on this material next class using the substitution method, so make sure you know how to substitute. That quiz is going to be based off of one of your questions on your homework. So make